everybody. This is your host, Shengun, of the show SG2 on Space, episode number 23. That's right, it's been 23 weeks. Not necessarily straight weeks, but pretty much, except for the holidays. So, with that, I would like to once again thank Action One Media for providing the studio and the room for it. Lovely logos behind us on that wall. So, of course, you are following both me and Action One Media. So, mine is facebook.com/The Shen Show, spelled TheShenShow. And of course, Action One Media is facebook.com/Action One Media, with a website at weara1.com. And of course, there's YouTube channels as well. So if you wish to see it, go to youtube.com this is my CAST725, CAST725. Eventually, I might change that name, but that's what it is right now. And of course, Action One Media has its playlist as well. So with that, just a note to you guys that next week I will be interviewing someone, but this week I will be talking the whole time, which is fine. So the guest I was going to interview this week, she unfortunately had a family emergency, so cannot make it, which is completely understandable. So, with that, I thought this was an interesting way to start out with a recent theoretical paper. All papers are theoretical. With a recent paper by an astrophysicist, Paolo Salucci, that hypothesized, I should say, that the Milky Way could be a huge space-time wormhole. All right, which completely blows my mind. So instead of the whole article is kind of long, so we have a little video here, which basically provides a brief insight into exactly what we're talking about when we're talking about black holes, and more importantly, what are wormholes, right? So they are related, but they're not the same. So with that, So, okay, hopefully you guys can actually hear this. Otherwise, there's some cool visuals, I suppose. This is only 2 minutes long, by the way. Okay. I wish their intro wasn't this long.
Einstein-Rosen mathematical wormhole arose from studying black holes. A black hole is a region in space of extremely strong gravity. The gravity is so strong that there is no way for objects that get too near to break away from its gravitational pull. Nothing can escape a close encounter with a black hole, not even light.
This inverted fountain serves as a visual analogy to what's going on around a black hole. At the bottom is the area inside the event horizon. And the water falling into it is analogous to gas that might fall into a black hole. Imagine yourself being a fish swimming around this region. Once you get down inside this central portion, you're past the point of no return.
But Einstein never intended his wormhole as a tool for space travel. His wormhole is theoretically created at some moment of time. It opens up briefly, through it will get crushed when it squeezes apart.
Okay, so with that wonderful note here and really dramatic music and dramatic voices, seems science program these days, want to make it exciting, so they gotta all spice it up. So point is, Einstein back in the day with his theory of general relativity, a natural consequence of that is the existence of black holes as well as wormholes, which the scientific word for that is the Einstein-Rosen bridge. Literally, it's a space-time bridge between space-time. So, essentially, there is nothing in general relativity that prevents you from actually having a wormhole in reality. Like, it shows that it could happen. However, physicists have said that a wormhole between distant stars, would collapse and pinch off before you have a chance to even go through it, right? So this is what, in the 1970s, Nobel Prize physicist Kip Thorne and a number of his colleagues show that, all right? Now, you could line a wormhole with exotic matter, whatever that is, to keep it open, but unfortunately, we don't know anything that has those particular properties, right? So, for better or worse. Okay, so, but that doesn't stop other scientists, from trying to figure out ways to do this. So, essentially, so for instance, a crazy one is in Trieste, Italy, astrophysicists from the International School for Advanced Studies, SISSA, in 2015 said that it could be manipulated within dark matter inside the Milky Way. All right. So based on their theory, and this is wild, our galaxy could be a huge wormhole or space-time tunnel. And if that were true, it would be stable and navigable. Navigable? I don't even know if that's the right word. But point is, that'd be amazing. All right. So, and the crazy thing about this is that we could possibly test it experimentally. So a lot of these theoretical ideas, how would you test it, right? So what you would do is you can compare two galaxies, our galaxy and another one that's very much like it. For instance, Magellanic Cloud. All right. So what we would do is that we need to have an extremely detailed map of the distribution of dark matter in the Milky Way. All right. So and then basically see if those have any discrepancies. All right. So if we have shown this, then that'd be pretty wild, I would say. So this guy Salucci, I'm supposing he's Italian, has said that we should take this issue seriously, and that for all we know, dark matter may be another dimension or a means of a major galactic transport system. So, and also there is a possibility of, he also said the dark matter could be made of a particular particle called the neutralino, which sounds very Italian, and who knows if that's actually true. Nobody knows what it is, right? So we shall see what's going on there. So this article, I put it up, and all you guys can read it and possibly understand some of the science. I don't know about the equations, probably not. So there's a note about these theoretical science papers. Unless you understand math and physics, you can probably read like the first two paragraphs and the last two paragraphs for the conclusion, and then skip everything else in the middle, because that's all fancy math and physics. So with that, let's take a short little break. When we get back, we're talking about the great beyond, which really what we just said was a great beyond, but let's tone it down a little bit and go back to our solar system. All right. So, all right.
Action 1, inspiring action.
So I challenge you today to start strong.
Start the revolution. When we
turn up, we shut it down. We are skywalkers, the spheres of my Kabbalah, illuminated properly in sight. Shows the man in universe and the creator's gift of life. When the earth collides with every piece of star from afar, there's a higher probability of
I'm calling for you. Can you feel that? Yeah. See, I'm calling for you. Can you feel that? Yeah. See, I'm calling for you. Say how you really feel. Say how you really feel. Yeah. Baby, just keep it real. Baby, just keep it real.
What's up, everybody? It's your girl Janetta, and I am still live at the Indie Fest. This is A1 Live pop-up, and I am here with the organizer of this amazing event. This is Mr. J-No, the Sun King. And J-No, I know you're more than just...
All right, guys, we are back. You're listening to SG2 on Space, episode number 23. This is Shen Gut, S-H-E-N, last name G-E. You are watching us, hopefully, at facebook.com/Action1Media, facebook.com/The Shen Show, THESHENSHOW, or our YouTube channels, YouTube channel for Action 1 Media, as well as mine at youtube.com/CAST725. All right, so before we went on break, we were talking about the really ridiculously wonderful theory that our whole Milky Way galaxy might be a wormhole, which is quite interesting, and I will share that paper with you guys later. So with that, let's jump into something of more recent discovery, actually, not just theoretical, is that we have discovered the most distant solar system object ever seen in our solar system, which is 140 astronomical units away. That means it's 140 times further away than the Earth is from the Sun. So 1 astronomical unit is basically the average distance from the Earth to the Sun, all right? So let's give you some perspective. Pluto, which is pretty far, right? That has an average distance of about 39.5 AU. So this thing is more than 3 times as far away as Pluto, which is ridiculous. So far away. So far away that it's given a name, maybe, hopefully it sticks. Right now it's just dubbed far, far out, literally. That's what astronomers are calling it in the media, far, far out. So creative. But no doubt there's going to be a scientific name giving it to it soon. So how much do we know about this? Nothing, all right? So this team led by Scott Shepard of the Carnegie Institution for Science in Washington, D.C., they literally just found it. And it's extremely faint, and it's pretty much one of the dimmest things we can actually discover, right? So, yeah, I mean, there's really not much more I can say about what it actually, actual details about it, since we don't know anything. Let's just say that this far, far out is actually not as absurd as you might think, the name. It's a nod to Far Out, which was a previous distance record holder, whom was actually discovered by the same team. And Far Out, which is now officially known as 2018 VG18, is about 120 AU from the Sun. All right, and so that object takes about 1,000 years to complete one journey around our Sun. All right, which is ridiculous. So this one, gosh, who knows? All right. Okay, so now I'm going to tell you that the distance records we're talking about here are for the object's current locations, all right? So there are objects, these orbits are highly elliptical, which means it's not a circle. It's very like an egg. It's squashed, extremely squashed. So it could get close to the Sun, relatively speaking, still really far. And then you can go up really far, like hundreds of AUs away. For instance, the dwarf planet Sedna, SEDNA, it could get more than 900 AUs away. All right, so there's also, of course, there's other stuff that we know is out there that we haven't observed, but that we haven't observed out there, but it comes into our solar system. For instance, comets. All right, there's about there's probably trillions of comets in what's known as an Oort cloud, OORT cloud, which has a cool name. Oort cloud begins at about 5,000 AU from the sun, which is 5,000 times further away than Earth to sun. That's really far. So these comets are out there for years, thousands of years, before they come into the range where we can actually detect them. All right. But this is still really cool. So another thing that's to be noted is that remember how Pluto used to be planet 9 until we said, okay, it's too like the other dwarf planets. There's really not that much difference. It's about the same size, really. So then Pluto got demoted to a dwarf planet, and we said, okay, there's only 8 planets in our solar system, guys. Well, guess what? No, astronomers, this is another story, kind of related, since the same team is looking for that, is that we do have a 9th planet, because if you look at the orbits, it doesn't match up. If you look at the orbits, planet 9's orbit, there should be a planet 9, all right? So the same folks, Shepard, who's discovered these really distant objects, they've actually been trying to find planet 9, the 9th planet. So it is observationally testable. So in other words, we could actually one day see real images of planet 9. So it's obviously really hard to do. It's like finding a needle in a haystack. In fact, it might even be harder than that. But it is possible. So how large is it going to be? It's going to be 10 times more massive than Earth. So it's definitely huge, all right? So that's why we call it a planet, okay? It's not like a dwarf planet. It's not like Pluto. It is actually a fairly large, decently large planet that's out there, and that's really far away. It is predicted on average to be 600 AUs from the sun. So Shepard, the same guy who discovered far out and far out now, says that there's 85%, he believes, 85% probability that planet 9 exists. All right. Now, as far as finding it, we shall see. I think once we find it, that'd be definitely worldwide news. It'd be like, oh my gosh, 9 planets again. So, speaking of which, I'm just going to mention that there's also talks about planet X, 10th planet. Way further out there. Let's focus on planet 9 first before we talk about planet X. All right. But yes, some astronomers have said that there is a chance that there's also a 10th planet as well. And that'd be even further away than planet 9. Gosh, so who knows where that is. All right. Okay, but planet 9 has a very good chance of being there. You just need to figure out where. All right, so speaking of something which we know for sure is there, and we actually have clear images of it, a couple of episodes back, I talked about Ultima Thule, right? Ultima, it has a cool name, ULTIMATHULE. And on December 31st, the New Horizons probe, which went way past Pluto now, has conducted the first flyby, so it went around it, of this Kuiper Belt object, all right? So, and we have our first clear images. We have them. So, just recently, NASA has released some more images, and they are absolutely amazing. So, they're obtained by the New Horizons spacecraft's Long Range Reconnaissance Imager LORI instrument just 6.5 minutes before the spacecraft made its closest approach. All right. So prior to this latest release this week, the most detailed ones were acquired 30 minutes before. So this is like the closest here. And it has a resolution of 33 meters, which is 110 feet per pixel. So which is pretty darn amazing. And so, just to know about New Horizons, it was the first dedicated mission to go to Pluto. All right, so it went to Pluto in 2015, and took like really detailed images of Pluto's surface, which we learned a lot about geological history. And then it went past Pluto, and now it's pretty much heading out of the solar system. But on its way, while it's still working, we might as well have it go visit other things that are of interest, right? That's on the way. So, now, why are we interested in Ultimate Thule? One thing is it could have maybe it has moonlets or a ring system, right? Also, these are Kuiper belt objects, which we don't know too much about. Kuiper belt objects, by the way, are objects that are pretty much beyond the beyond Pluto out there. And beyond Kuiper belt is the Oort cloud, which, like I said, is really far away. So with that, I think we can watch a little short video, very short, and it basically shows the close-up images. And that is literally, that's it. That is basically it. But also, that doesn't look terribly impressive. Just imagine this is a spacecraft that's more than 40 AUs away from Earth, taking pictures of a piece of rock. Okay, but that's pretty cool. I mean, it looks really interesting. All right, so with that, I don't know what the next trip would be, but who knows? I'm sure New Horizons would hopefully find something else to see. So with that, let's jump into beyond our solar system again. So I want to talk about the last thing I want to talk about in the great beyond before we jump into those space cowboys doing crazy things like closer to Earth. Let's talk about unions based on another NASA mission closer down to Earth called NASA's Spitzer Space Telescope. All right. So, remember a little while ago when I said, and this is related to a few episodes back, I was talking about how the Milky Way galaxy and Andromeda galaxy, the two biggest galaxies in our local group of galaxies, literally called local group, that we're going to collide and merge together into this gigantic galaxy, possibly. So now, how can we know what's going to happen prior to that? Well, thankfully, we can observe, thanks to telescopes such as the Spitzer Space Telescope, observe other galaxies that are merging, right? So only a few percent of galaxies in the nearby universe are merging, but we can still look at that data, all right? So now there is a thing of like, hey, what happens after the galaxy merges? It turns out it's not all very happy, all right? The chance of anything colliding with each other is pretty low. Happens. So there is a sudden halt in star formation inside a merged galaxy. So that possibility might be due to an overfed black hole. So just a note here, at the center of most galaxies, there is a supermassive black hole. Our Milky Way galaxy, for instance, in the center of it, I forget how many light years across it is, at least like 30,000 light years across. There's like a gigantic black hole. his Virgin Galactic company is supposed to bring, well, at least initially, really rich people into space and then back. So it's like your spaceship. Um, Initially, as just give you a quick note, Virgin Galactic is what's known as suborbital. Okay, so in other words, it doesn't fully go into space and stay there. It goes up, you experience weightlessness for a few minutes, and you come back down. All right, which is still kind of cool and way cheaper and less technically challenging than actually building a orbital spacecraft. All right, so with that, yes, this is wonderful. So that is what looks so futuristic. It has basically an airplane, a specialized airplane carrying a suborbital, um, basically what's known as Spaceship 2 spacecraft right below. See that? That's amazing. It deploys that and then fires his rocket engines, VSS Unity, and it goes up. And then this thing, so it's a aircraft plus rocket. So, which is, and those are real, by the way. They're not models. This thing's pretty darn amazing. So this is, it peaked at 89.9 kilometers, which is 55.87 miles. And that is slightly above what the U.S. Air Force defines as the boundary of space, which is the second time that Virgin Galactic spacecraft has surpassed that boundary. Wow, that pilot must be having a lot of fun. So it's a little bit higher than its previous flight than the first time it went over, which was last December when I mentioned it. So, however, according to some people, it has really not hit space because the Kármán line is 100 kilometers, and that's what the International Astronautical Federation considers to be the beginning of space. All right. So, okay. So, how much do you need to pay to fly on one of these things? Once it's ready, of course. $250,000. All right. So if you're a millionaire, you don't have to be a billionaire for this. If you're a multi-millionaire and you're willing to dish out $250,000, then you can fly in this thing for a few minutes, right? I forget exactly when. I think it's less than an hour. You go up there, weightlessness experience, and you come back down, and of course you get to see Earth from way up there. So Richard Branson, being a daredevil he is, he founded the company, and obviously he has some money, and I don't even know if, frankly, he... yeah, pretty darn cool. So I'll post up the video. You guys could watch it later, and it's pretty crazy. So with that, let's move on to... This video goes on for a while, I'm sure. A beautiful view. Let's move on to SpaceX, which a lot of folks have been really paying attention to because SpaceX is launching its first test Crew Dragon capsule this Saturday. So let me tell you why this is important. Ever since the space shuttle retired, we've actually been dependent on the Russians to get us into space for humans. All right, and that is that's been going on for quite some time now. So we had no native capabilities to America to go into space since 2011 for humans. July 21st, 2011 to be exact. That was STS-135. So how long has it been? It has been like more than 8 years now, almost 8 years. All right. So for 8 years we've been dependent on Russians, and now with a focus on more commercial development to support NASA, NASA is not going to build another space shuttle or anything like that. Instead, we're depending on companies such as Boeing and SpaceX. So Boeing is developing the CST-100 Starliner, which hopefully is going to do a demonstration flight sometime this year. SpaceX is going first apparently with its Dragon capsule. So SpaceX already has a unmanned version for sending up stuff, payloads up and down. So now it's going to launch the first test flight of the Crew Dragon vehicle. Now there's no astronauts in this thing because this is the first test of it actually going into space. So yeah, that's pretty amazing. Ideally could fit 7 people, which is quite a lot, I would say, and it's 27 feet tall. So now this vehicle that's going to be launching this Saturday, March 2nd, it is going to be carrying a passenger. It has a dummy, all right? The dummy is going to be wearing the company's black and white spacesuit, all right? So, yeah. But the technical term is not dummy. It's called ATD. Since NASA does not like to call anything dummies in there. It's called, well, actually, weirdly enough, it does have the word dummy for it. Okay, ATD stands for Anthropomorphic Test Dummy. Come on, they could just call it dummy, but all right, fine, call it ATD if you want. So, in any case, the ATDs, the reason you have the dummy / ATD up there is because it's humanoid, right? And it's wearing a spacesuit, and it has all these sensors all around it. And these sensors are going to sense loads and stresses. So that would tell whether, hey, you know what? You're suffering like 20 G's here. An actual human would die, all right? Which is not good. You don't want to send an actual human in the first test flight. That's why you have this dummy thing, ATD, with a bunch of sensors around it, all right? So this Crew Dragon is based really heavily on the robotic Dragon capsule that has been doing this for NASA since 2012, right? The difference is that the Crew variant obviously has seats. It has 7 seats. It has a life support system. It has an emergency escape system, pretty important. It has touchscreen displays. It has windows and other, passenger-related things, right? So, also, the Crew Dragon solar panels are built into its trunk, and the capsule will dock directly to the orbiting lab. Versus the robotic Dragon, it has traditional deployable solar arrays and is grappled by the ISS huge robotic arm. So this one will dock without the use of a huge arm. All right. So this upcoming flight, uncrewed flight, Demo 1, it will put the Crew Dragon into. Okay, yeah. So that's a cool picture actually or video of the Dragon, of the current Dragon, not the Crew Dragon, docking and undocking. And you saw that robotic arm grabbing it. Okay, so any case, this is going to be a 6-day mission, and if everything goes according to plan, the Crew Dragon will depart on March 8th. So depart the space station on March 8th, and make a parachute-aided splashdown in the Atlantic Ocean. So then after that, it's going to fly a high-altitude abort test in next couple of months, proving that the emergency escape system works. And then there's going to be a Demo 2, which will carry 2 NASA astronauts, real folks, not dummies, to the space station in July this year. This is super exciting, all right? And then, assuming that works fine and nobody dies, okay, cross my fingers, or everybody, then we're going to just start doing regular flights, which would be awesome, all right? And of course, Boeing's going to do them too. So we're going to have at least 2 companies that's able to provide it. And in fact, in the future, we might have 3, because Sierra Nevada is developing the Dream Chaser, which could also fit humans. And we shall see what happens there. All right. So there's a bunch of American commercial companies that's going on here. So, any case, that's pretty awesome. Now, just a note, the Americans are not the only ones doing cool stuff. I would like to say that Israelis are doing something cool too. Let's see if we can watch a short video about, I think I mentioned about them last time. So this is jumping from America to Israel now because they're doing something really cool. They have built Space IL, which is an Israeli space company, has built the first private lunar lander. And look at that. This is their plan, right? They've already launched, by the way, Falcon 9. They released a Beresheet spacecraft. It's releasing to elliptical orbit. So essentially, it's going to swing around. All right. And okay, basic orbital mechanics here. When it gains altitude, it loses velocity. In other words, it slows down. All right, so it begins heading back towards Earth, loses altitude, but then gains velocity, right? And it will complete full orbits and obviously not hit the Earth. And so basically, it's going to use Earth as a means of gaining more speed. All right, so and making sure it positions itself right for the moon. Okay, so that's great. So every time it does this, it gets higher and higher. All right, you see that? So it does that loop. Why are they doing this instead of going straight to the moon? Probably because it saves on fuel. And this is a very tiny spacecraft. Okay, and it has a lander, but it's still pretty tiny. All right, so eventually, didn't realize the simulation actually takes a while, but you get the point. It eventually reaches the stage where it intersects with the moon's orbit. Now, this is really cool, but unfortunately, what happened on February 25th, on Monday, was that it missed a planned maneuver to steer the spacecraft. It's along its 8-week journey. So it was originally scheduled for 5 p.m. Eastern Standard Time on Monday, February 25th. However, the spacecraft computer reset. It caused the maneuver to be automatically canceled. And they're looking into, okay, my gosh, what can we do, right? So don't worry. It's not like the spacecraft is dead. They just need to, make sure that it fires its thrusters at the appropriate time. So eventually... So this spacecraft, by the way, was launched on February 21st. It's supposed to land on the moon's Mare Serenitatis, which clearly the simulation has not even gotten there. But point is, it's eventually going to land in the Sea of Serenity on April 11th, all right? So it's going to take about 2 months for it to do that elliptical loop thing and then orbit the moon, complete several revolutions around the moon before it lands. All right, so... And then after it does that, it's going to land. It deploys its landing legs, and so they will land. Now, how large is it? It's about 5 feet tall, so that's 1.5 meters. It's going to spend 2 Earth days on the moon. It's going to take photos, do measurements, typical good stuff, and it has a Israeli flag, very proud. A time capsule, a lunar library containing the full English contents of Wikipedia, wonderful, and more for the Arc Mission Foundation, as well as a laser reflector experiment for NASA, which I presume is you can shoot lasers at the moon now and have it bounce back. Apollo astronauts left something behind too. All right, so this whole thing, this $100 million lander, Beresheet means in the beginning Hebrew, by the way. It was a joint effort between Space IL, the Israeli company, and actually, sorry, that's a nonprofit, Israeli nonprofit, and the company Israel Aerospace Industries, IAI. Originally, it was a contestant for Google Lunar X Prize. Unfortunately, nobody won that because the time ran out, but that's fine. At least they're doing this for real, regardless. Money or no money for the contest. Okay, with that, we're going to take a short little break. When we come back, I'd like to talk about really crazy stuff.
There's a formula. If you follow the formula, you will be successful.
Facts.
You will make it. There's no way that you won't. So I was like, I'm going to listen to all the advice that I can, figure out what this formula is, and then follow it. Now I'm interested in learning how to code, and I'm realizing that program that she did is probably similar to what I would need. So the plan was to spend a few months saving and studying, 3 months of school, 3 months of job hunting, and all of that together put me at a year. Hearing the stories of people who've done exactly what I'm trying to do was very reinforcing. It's not trying to make it to the NBA.
Okay, so you guys are listening to SG2 on Space, episode number 23. And this is your host, Shen, S-H-E-N, last name G-E, Shenge. And of course, supported by, or in the studio of Action One Media, which you can find at weareA1.com, one as in the number, not spelled out. Or facebook.com/Action1Media, and there's a YouTube channel as well, which will be shared. And of course, my show at facebook.com/The Shen Show, THESHENSHOW, and my YouTube channel at youtube.com/u/cat725. Yeah. So with that, let's talk about something super strange, because that's what I like to do, right? I'm either talking about aliens or like weird parallel dimensions or something. Well, this time we're going to talk about simulations again. The fact that not just simulations, but possibility that there's multiple universes or weird things going on as well. So for instance, there's a number of reasons why we could possibly be not living in the only reality at all. So let's start with this thing called the Mandela effect, which I found really interesting. In fact, I follow this Reddit site. Reddit is a website where you guys can, well, anybody could find really anything, like an online forum, all right, for pretty much anything. So one of the ones is Mandela effect, which is basically people saying that things are changing on them. So have you guys ever, like, say, put your pen somewhere or put your keys somewhere, and then like the next morning say it's not there? Or have you guys ever remember something like some TV show in the past, you thought this actor was in there, and then it's like they're not there, like you're just imagining it, and you're like, what the heck? Yeah, so it's called Mandela effect because Nelson Mandela is obviously extremely well known around the world. And some people remember him dying in 2013. Oh, sorry. Okay, he did die in 2013. Some people remember him dying in the 1980s before he was let out of jail, right? So there's quite a number of people who believe that. And there's also, so essentially what this may mean is that some people have crossed into another universe where, well, they came from another universe where he did die in the 1980s, right? And so they have those memories still there. So it's kind of like, say I wake up tomorrow and somehow this famous person I know is dead. Like, say I go into that universe where Nelson Mandela died in the 1980s. Then I would be totally freaked out, right? I'd be wondering, did that really happen? Now, considering how good, like, how I know for sure that he did not die in the 1980s, at least in this universe, if suddenly I wake up tomorrow and I read on Wikipedia or something, and that is the case, I'd be like freaking out like hell. I'd be like, oh my gosh, this is crazy. And of course nobody will believe me because they think I'm crazy because I have shifted universes. Anyways, that's the thing, right? Stuff like that. There's also things like the Berenstain Bears children's book, and how it's misspelled. Misspelling happens a lot in terms of these Mandela effect shifts of reality. As well as like Shazam. Some people think there was a movie called that. No, except it isn't. It doesn't exist. That's the thing, right? At least not in this universe. So yeah, all sorts of things. So here's the thing you guys could do. This is actually one of the ones that you can do. Just pay attention to stuff. Alright, okay, that's very general. The point is, pay attention, notice every day that if there is a change that you haven't noticed before, and not just a change in not necessarily just a change in where you misplaced your keys. That was a bad example. But more of a change like overall, okay? And it doesn't have to be as major as Nelson Mandela dying on different years. It could be something like, hey, wait a minute, I thought Chick-fil-A, for instance, was spelled this way. And in fact, that's one of the other examples. Alright? So pay attention to that. Alright? Who knows what's going to happen? I mean, you may be switching universes all the time. Remember that story? I'm going to briefly mention this. I think an episode or two ago, I talked about the story where this lady woke up and she was lying with this, she was in bed with this man who was her ex-boyfriend, who she broke up with a couple months back, but apparently she switched universes and they never broke up, and then her job was different as well, and it was all messed up, and she's like, I'm not crazy, I just want to go back to my own, like, what is going on, and obviously, oh well, you're kind of stuck in our universe. So that's a super extreme example right there, okay? But I do think these things do happen. So, and if you want to read more on it, go to Reddit and look up Mandela effect. So, with that, let me talk about something a little more physics-oriented instead of memory, or, you know, you might be like, okay. So, you know, there's a famous double slit experiment which seems to show that quantum mechanics are real, and quantum mechanics has been demonstrated to hold for pretty much every single thing thrown at it. So what it's doing is that electrons, or all particles, are both, all stuff is basically both particles and waves, right? So electrons that's fired at a sensitive, photosensitive screen through two slits produces interference patterns, right? That indicate wave-like behavior. But when you observe it, they behave like particles, which is crazy. Now, it's just a quirk of quantum mechanics, but some people say our simulation is conserving its resources, and we're only rendering certain things when we're looking at them. So it's kind of like a computer game, right? It's like it doesn't simulate the whole environment, it only simulates the things when you're looking at, like, over there, okay? I personally think that's too crazy. I don't think that's true at all. I don't believe that idea. The Mandela effect, for me, seems more plausible in terms of that. Okay, so moving on, DNA with computer virus. So in 2017, this is intriguing. So a group of researchers at the University of Washington proved that they could embed computer code into physical strands of DNA. All right, and their aim was to show that computer working in gene sequencing were vulnerable to attacks. So it included malicious computer code. But what does this show? Maybe what we call DNA is really computer code all along. So in which case, we're just simulations. Who knows, right? Okay. Weird. Have to read up more on that. Another thing. Climate change. So our civilization, right? So here in this country, unlike the rest of the world, not going to go into politics here, but we for some reason do have a lot of debate on whether climate change was even I don't know why, because if you look everywhere else, people say climate change is definitely happening. All right, so anyways, I'm not saying, okay, whatever. Point is, our civilization is undergoing environmental change, right? No matter whether you think it's human caused or not. So climate change is happening, whatever is happening, whatever reason. Now, there's some people out there who thinks we are put into this scenario so that we can figure out how to resolve it. Like, we're going to figure out a solution. And then these aliens who made our computer simulation is like, oh, okay, so that's how we can do it. That's how we can fix our environmental issues. All right, this is way out there, right? I'm like, okay, really? I don't know about that. Okay. Then video games, right? So Elon Musk, for instance, believes this. He's a believer in Nick Brostrom's simulation hypothesis, which I talked about a few episodes ago. So Elon Musk, who wants to go to Mars and Moon and SpaceX and Tesla and all that jazz, I would think that he wouldn't think we're just all simulations, but wow, I guess he does. So he said 40 years ago we had Pawn, right? The game where we had like two rectangles and a dot and you kind of hit it. It looks really lame nowadays. Now, 40 years later, we have photorealistic 3D with millions playing simultaneously. I'm just quoting his words. If you assume any rate of improvement at all, then the games will become indistinguishable from reality. Even if that rate of advancement dropped by 1,000 from what it is now, it's a given that we're clearly on a trajectory that we're going to have games that are indistinguishable from reality. It will seem to follow that the odds rating of base reality is 1 in billions. In other words, he thinks that it's extremely unlikely we're actually reality. All right. I don't know what to think here, but hey, you know, who knows? I would hope that we're not video games, but whatever. All right. Then James Gates, right? You guys know who James Gates are. Pretty famous, I guess, theoretical physicist and clearly a speculator into, you know, a lot of theoretical physicists do this, right? Speculate about philosophy as well. So anyways, so he claims he's identified what appears to be actual computer code embedded in the equations of string theory. So he says he found error-correcting codes. They're what, for instance, like web browsers, error-correcting codes. So why were they in the equation he was studying about quarks and electrons and supersymmetry? Gosh, maybe it's because we're actually a computer software. All right? Who knows? I mean, wouldn't that be wild? All right. So, okay. Then another thing, MIT cosmologist Max Tegmark, who once again is another one of those scientists who love to speculate. So he points to our universe's laws of physics as possible evidence we live in a video game. So he says, if I were a character in a computer game, I would also discover eventually that the rules seem completely rigid and mathematical. So in this theory, for instance, the speed of light, the fastest rate at which any particle can travel, represents the speed limit for transmitting information within this network in our simulation, which is pretty darn crazy, but hey, could be, right? Okay, then another one, glitches in the matrix, which is all the stuff that I love to talk about. For instance, alien encounters, people slipping into dimensions, blah blah, weird things happening. I don't ever talk about paranormal events unless you're counting Bigfoot or stuff like that. But ghosts and things, okay, I don't talk about those. But point is, whatever, all those things are just glitches in simulation, like the Matrix, right? You guys seen the movie The Matrix? There's glitches, and it's like, okay, you know, those glitches come from software viruses or some kind of the code wasn't done right. All right. So and essentially there is a whole bunch of glitches you guys could look at. For instance, on Reddit, if you and I love reading those because, you know, I'm constantly thinking whether our reality is true or not. You can go to Are We Living in a Simulation? That subreddit, or literally glitch in the matrix. So, yep, glitch in the matrix. Lovely. So basically, people post up real life encounters. That is weird. For instance, there's examples of a storefront existing in town one day, then it disappears, or a slip between timelines, or a slip between universes, like that lady who somehow, you know, ended up with her ex-boyfriend again. Doesn't have her job. Okay, that really sucks. But point is, or more commonly, objects mysteriously disappearing and then reappearing, and for sure them not actually having bad memories all the time, and or missing time. Like there's cases where people are doing one thing and then like 30 minutes later they're like, look at the clock, and it's like 5 hours pass. It's like, what the heck happened? Like they did not fall asleep. It's just suddenly like that. or cases where time shrinks. Like this guy was going to work. It was supposed to take 30 minutes. He gets to work, checks his clock, and it's like 5 minutes past. That's just crazy. So there's stories like that too. Now, are they made up? Who knows? Anyways, also elevators. This is interesting. Elevators frequent setting for glitch stories. There's a jump between floors. So, guys, if you're ever in an elevator, look to see what floor you're on. And if you're suddenly, next second, you're on like the 30th floor, assuming your building's that tall, or on the first floor all of a sudden, you have just slipped into some other time or dimension or something. All right. So, yeah, go read this stuff. Some of it's really wild. All right. Okay. So, another thing, pixels, right? Okay, we all know what pixels are on our computer screen. Pretty much, they're the smallest display we can see, right? So, you know, the more pixels you have, the more detailed your graphics are, right? So, according to simulation believers, we may already have found the pixel-sized building block in the universe, which is called the Planck length. Planck length. All right. So Planck length essentially is the smallest that we can ever observe. Theoretically, that is the limit. So that is a unit of length that light travels in 1 unit of Planck time, and it's extremely tiny. It's 1.616 times 10 to the negative 35 meters. All right, that you can't even imagine how small that is. But point is, it's not 0. All right, so beyond that, the theoretical physics say that you can't observe anything like beneath that length. All right, so what does this mean? Well, people think, hey, that is a pixel. All right, so our pixel might be like what, 1 micron or whatever, however long, 1 millimeter. Gosh, I don't know. But point is, eventually, maybe a computer will be able to simulate down to that level. All right, and it can't simulate ever further. That's why we have that limit. So, you know, that is yeah, that's pretty wild. So, by the way, just a note here, there's something known as quantum foam as well. So that is related to the Planck length in that, so essentially quantum foam, which is not like your soap bubbles or soap foam or your sponge for your kitchen, is literally the when reality goes down to the tiniest levels imaginable, space-time itself fluctuates, so nothing is static. All right, so it fluctuates, and it is basically things are popping in and out of existence. It's like, it's super weird. All right, and physics hasn't quite mapped out what it looks like yet. All right, so point is, at that level, that's about the same length scale as a Planck length. All right, so okay, and lastly, you know, our brains ourselves plays tricks. Okay, so remember, there was that photo where some people saw a blue dress while others saw a white dress. I mean, while others saw a gold dress. Like, for instance, I see a gold dress right here. Okay, but some people might see blue, right? There actually have been. And there's also the blue, gold, white flip-flop debate of 2016. So what does this all mean? Well, you know, this may not be nearly as mind-blowing as some of these other things, but it does show that our basic brains have trouble, or rather have our brains, each of our brains are different and interprets reality differently. All right, so, and it has been shown to be true. Like, for instance, what I see as yellow, say, is actually different than what you see as yellow. And this is based not on just biology, but also on cultural things. And so there has been these societies where all they see is, because of where they live, it's like in the desert somewhere, and all they see are like black, brown, like shades of gray and shades of brown, and sometimes blue, right, the sky. So they don't see like other more vibrant colors. And they have shown, anthropologists have shown, and sociologists and psychologists, and vision scientists have shown that they actually cannot identify the colors we can identify. So for instance, some of them can't see, like, say, purple, say. Like, to them, it looks exactly like some other color. However, on the other hand, they're able to distinguish fine colors which we cannot distinguish, like really tiny differences between, like, 2 different shades of red, for instance, which is pretty wild. So what does this mean? This means, well, even our brains are playing tricks on us, not just the universe, all right? Like, we're limiting our perception of reality, not just reality itself, but our perception of reality. So with that, I think with all this, you guys have a lot to think about. But before we end this episode and I say goodbye, I want you guys to know that never forget about what's flying up there, all right? So despite all this reality shifts, there's still UFOs flying, and you should still look up. All right, so look up. You don't know what you're going to see. And be very perceptive of your surroundings, because your reality might be shifting any minute. So this has been episode 23 of SG2 on space. This has been your host, Shingun, and I would like to say have a good night, everybody. And once again, follow Action One Media, facebook.com/Action One Media, and follow me, facebook.com/The Shin Show, and the YouTube channels will be shared shortly. So take care, everyone.
Peace, it's Brother Atum Ra, and you tuned in to Action One Network.
I'm calling for you. Can you feel that? Yeah. See, I'm calling for you. Can you feel that? Yeah. See, I'm calling for you. Say how you really feel. Say how you really feel. Yeah.